Okay, so that's first paint. And once those pixels start painting, we can move on to our next paint metric, which is LCP, or largest contentful paint. So when we're talking about this metric, we want to get the stuff that loads in a non-blocking way to show as soon as possible. And it's the large parts of content that make up the focal points of the page content that we want to render fast to really nail this metric. And when we talk about optimizing for this metric, there are some key components that we want to pay attention to. We want to make sure that we can fetch important assets as early as they're needed. We want to make sure that our images are delivered properly, so they're sized and targeted appropriately to the right devices and screen sizes and connection speeds. With our fonts, we want to look into loading strategies that load fonts progressively so that we can show content sooner than some web font loading strategies might otherwise do. For JavaScript, we want to make sure that we're enhancing the layout of a page in areas that JavaScript is used heavily without adding any jankiness or reflows to the way the page is presented initially. And then we want to look at our third-party JavaScript and make sure that it's loading without blocking content that comes after it in the page source. So a lot to think about in this section. I'll go over these in a little more depth. So one thing that can make a world of a difference with first meaningful paint is getting requested assets to the browser sooner. And we have a lot of tools that start with pre that help us in doing that. So I'm going to cover those next. So in the case of this first one, we have link rel preconnect, and that asks the browser to perform a connection to a domain in advance. This is useful when you know that the browser is going to be connecting to a third-party service further down the page, and particularly when the browser won't discover that resource before requesting another file first that ends up making that request. So you can kind of get ahead of where the browser would otherwise be later in loading by pre-connecting to third-party domains ahead of time. So for example, if you had a CSS file that referenced font files on a third-party hosting service, this would be a way to connect to that server early to save those early connection and DNS steps when the files are actually requested by the browser. So that's rel preconnect, and you can just put this in the head of your page with the domain that you want to pre-connect to ahead of time. Here's another one, DNS prefetch. Preconnect is a step further than this one, which only does the DNS resolution step. Preconnect does this step and makes the secure connection. So I'd recommend using preconnect instead of just DNS prefetch. Here's another one, link rel preload. This one tells the browser to download and cache a resource like a script or a style sheet as soon as possible. And this one is mandatory. It can really help if you're really careful with how you use this. To give you an example of that, this timeline shows a comparison we did with rel preload. We preloaded a script that was otherwise going to be dynamically loaded from the HTML in a way that the browser wasn't going to see early enough. So it was a dynamically generated script tag that the browser wouldn't notice in its early scanning of the HTML. So it wasn't getting requested soon enough, but this script was very important to rendering content in the page. They were relying on third parties to generate content, which is a very common pattern, often a problematic pattern in a lot of marketing websites when third-party services are used to drive A/B tests and different personalized content. So in this case, the script was modifying the page for an A/B test, and it was critical to get that script loaded sooner so that when it was needed in the page, it could execute sooner. So we preloaded that script and we saw good results and ended up shaving about 3 seconds off the final view. So this tool is really handy if you notice a problem after the fact in an architecture that's kind of hard to work with. Preload might be a good tool to shuffle priorities and make sure things are loading when you need them to. And the as attribute was part of that link rel element. If I go back, you can see it's as script in this case because it's a JavaScript file. So if I go forward again, there are other as values that you can use like audio, document, embed, fetch, font, image. So you can see these line up with file types that you would preload into the browser to be used later as a particular type of asset. So generally, preload can work well, but I suggest testing it really heavily because it can actually slow things down if you preload things that shouldn't be very high priority. It can actually deprioritize more important stuff that would otherwise come in at a high priority. So use it sparingly, but it can be a useful tool. So generally, those pre-tags can help set the stage for the assets that you'll want to get into the page soon. But we don't need to prefetch everything. Many things come in naturally into a page rendering process when they're referenced normally in the flow, like images. So let's talk about images for a minute here. Delivering images seems easy at first from a performance perspective. Just optimize your file size like we talked about early on and drop an image tag into your page. And this is pretty good already because it will load without blocking rendering at least. So it has a nice asynchronous kind of default loading behavior. Unless, of course, it's a data URI source instead of an external source. Again, this is how you would sort of inline an image. And generally, it tends to be a bad idea for a number of reasons. It bloats your HTML by adding the entire contents of an image element into it. So even if it loads sooner this way because it's not external, it doesn't require an external request as soon as the browser notices it. It may be in the way of important content that comes after it that would otherwise load sooner when the image comes in on its own. So images tend to load asynchronously unless they're inlined like this with a data URI. That way they would block. But generally, data URIs are a nice tool to have, but rarely the tool we actually want. I just wanted to point that out. Images can block, but generally they load externally and asynchronously. That said, the default loading behavior of images can be problematic. So you might recall this reflow situation from the metrics section where this default behavior of external images loading is disruptive. It pushes the text content down or any content down that comes after the image. And you can see how that disrupts the content. It would totally throw someone off if they already started reading the page and they'd have to refine their spot in the text. And again, image loading problems like this contribute to the CLS metric in particular. So big layout shifts come from this problem. This doesn't necessarily mean the image needs to load sooner, but it's great if we can sort of prop open room for the image so that it has room whenever it does arrive. And thankfully, browsers are starting to help us do that a lot easier. So if you bring back those old width and height attributes that we've sort of stopped using in the responsive design era because we have fluid images, but if you bring back these width and height attributes, they actually work as a little hint to the browser for the aspect ratio that it should expect for that image. And so browsers are actually starting to paint a blank box for space for where the image will fill in whenever it arrives. And this is great for rendering performance. So start using these attributes again. They don't have to be literal as far as how the image will render. They're used for aspect ratio. So you can still use CSS to size the image however you'd like, and these will help so it scales proportionally. So early on in this section, I talked about optimizing images for delivery, making the files themselves smaller. That's not everything we need to think about with images, though. We also want to make them responsive. It often makes sense to offer different versions of an image based on browser conditions like viewport size, screen resolution, or even network conditions. And our web community has worked very hard in recent years to develop new standards to make this really easy for us to manage. So source set and the picture element are new web standards in the last few years, and we can use these to send browsers an appropriate image size or crop of an image without using any fancy JavaScript workarounds. They're supported in most browsers now, and both have really nice fallbacks built in. So I'm going to go into each of these. First, I'll talk about source set, which is an attribute addition on the image element. So it's the same old element that we've been using, but we can now add new attributes onto it for source set, which I'll cover first. Source set is a way to offer more than one possible source for an image, separated by commas, so that the browser can choose an appropriate one based on the conditions that it deems relevant. And for each source, you can specify width that goes with each of the image sources and says the natural width of that file. And you do that by using a W syntax. So 300W is equivalent to 300 pixels wide. 800W would be an 800 pixel wide image. So you can see how we're listing as many as we want for the browser to consider. And then to pair with those sources in the source set attribute, we have a new attribute called sizes. And this attribute is a hint to the browser about the size of the image as it will be displayed in the layout when the page is actually rendered. Because the browser will actually encounter this image element before it has a layout to deal with. So it needs a little more information from us developers to say what the image will actually look like in the layout, how wide it will be. And we know that ahead of time. So again, it's comma separated syntax, and it's a little bit ugly, but it's powerful. What you do is you say the size of the image as it will appear in the layout, either across all viewport sizes or at particular ones. And if it changes, if it's, say, 50% wide at this series of breakpoints and then 100% wide of the viewport width at wider sizes, then you can separate those out with a comma once again. So the syntax for this is the first condition that matches will be kept. So if we read this particular sizes attribute, we can see that the image is displayed at 100% of the viewport width, so that's the VW there, at a max width of 500 pixels. So that means the image will be 100% wide in the viewport all the way up to 500 pixels of viewport width. And then anything wider than that, this condition will no longer be valid. So we'll go to the next one. And the next one says the image will be 50% of the viewport width. So with that information, the browser could say, okay, the viewport size is 300 pixels right now. So I know that the image is going to be 100% of that width. So I only need an image size that fills 300 pixels wide. So it can go to its sources in the source set and choose one that applies appropriately. Really rich information for the browser to use to decide which source to choose. So we're letting the browser decide. And sizes is actually more than a suggestion too. It's pretty prescriptive. In this article, if you want to check it out, I wrote on the Filament Group site, I showed how you can make an image magnifier tool that actually works by changing a sizes attribute between 100 viewport width or 300 viewport width. And I'm doing that on hover. So you can see just by toggling the sizes attribute, I can actually start to build the foundations of a zoom control. So what's neat about source set is it allows us to let the browser decide which image is appropriate based on what it knows, such as the user's viewport size, screen resolution, and possibly even connection speed or user preferences. In other words, with source set, we forfeit control over which image is picked in the end. The picture element is different. The picture element actually wraps an image element and offers specific sources at specific conditions that must be followed by the browser. So this one is more prescriptive. So picture is sort of a controller for the image that it wraps. And the image becomes a fallback that is used if none of the sources that come before it happen to match based on their conditions. So just like in source set, we go from first to last in the picture element, trying to use each source one by one. And then if none of them match, we'll go to the fallback image. So each source in the picture element can have a media attribute and a source set and a sizes attribute, just like images can. So why would you want absolute control like this? Well, picture is really great for art-directed imagery. See how this image is actually different crops of the same image that appear at different viewport sizes? Picture helps you do that level of control. These images can even have different aspect ratios, so that's really quite powerful. So where you have different crops per breakpoints, that's something that source set can't do as well. So this is a really specific case where the picture element is handy. You can also use the picture element to serve different types of images pretty simply, like WebP. I'm specifying on the source element a type attribute of image WebP, and if that happens to match the browser's support, then the WebP image will be used. Otherwise, it'll fall back to the image that comes after it, which is a JPEG. So that's a nice little pattern for being able to use WebP images on a static HTML site today. And that same technique is handy for AVIF format images too. Of course, there are downsides to the picture element. You can really misuse picture very easily. In many cases, SourceSet is more concise and smarter to use. Here I have an example where we have lots of sources with media queries for resolution and screen size, just trying to reproduce the smarts that SourceSet does with much more concise syntax. So often, image SourceSet is really all we need. Unless we're doing image cropping, image SourceSet tends to be more concise. However, there's a problem with SourceSet alone too. It's that if you use SourceSet and offer up a wide array of potential sizes, SourceSet alone can cause high resolution devices to request very large images that happen to suit the conditions of that device. Like if it has a 3x DPI screen, it could end up requesting a very, very large image, even though the level of sharpness is not really going to be perceivable to the user. It's just downloading a larger and larger image to no real benefit to the user. So sometimes our best bet is to use SourceSet, but with some constraints. Picture actually lets us do that. So here we're using source elements to sort of offer up two image source sets and make sure that they're constrained to max width viewport sizes. So if it's a max width of 400px, then you have the option of two images, but not the whole set. So a high DPI device would not end up requesting a very large image if they happen to have that viewport size. And then at viewport sizes up to 800 pixels, we offer a couple larger sizes. And then if neither of those sources match, well, then we follow it up with our fallback image, which happens to be the largest size. So you can see how these sort of play off each other in order of appearance, and you can stack them to get a desired result. So this just kind of protects the device from downloading something that's a little heavier than it could actually noticeably appreciate. So that's enough about your standard responsive images. Let's talk about SVG a little bit. So there are a number of ways to load external SVGs in HTML. There are actually a lot more ways than I've listed here, but these are some of the common ones. So we've got image elements, we've got the use element inside an SVG element, we've got the object element that's been around a long time, we've got background images. There are so many ways to load external SVG. And used this way, SVG tends to behave like any image. But SVG is special in some significant ways that are worth discussing. SVG is, of course, built from text, unlike many other image formats that are binary. It can be inlined in HTML like this because it's just text. So you can inline your SVG right in, and inlining SVG also has some performance implications. Inlining it can be guaranteed to have it there to render with your HTML, which sometimes if it's a very important icon or graphic, that might be worth it. Images tend to work well when loaded externally, but inline SVG is nice because styling these elements through direct selectors in CSS is really easy when SVG is inlined in the HTML, but not as easy or even possible when it's in an external file. So you can see in this example, it would be very easy for me to write a CSS selector to style the individual paths of the lines emanating from this antenna. But once it's external, we lose that direct ability to style individual nodes like that. But there is an exception. Here's a new pattern that I have been liking to work with that gives us a lot of the benefits of both. So CSS has custom properties now, which are like variables in CSS that can be defined in the parent document, and they magically carry through into external SVG files if you reference them in a certain way, such as with the use element. So you can use them to apply transforms, for example, or change the stroke width or color. Anything that CSS can control generally passes through using these variables. So you can see that here I've got an SVG that has a style attribute that sets the wheel color CSS property to red. And then in this external SVG, which is outside of the document, there's a path that happens to use a fill with that variable of wheel color. So its default might be blue, but if this wheel color overrides it and is passed through with a different color, then it'll use that, even though it's external. So you can start to see ways that we can control external SVGs really powerfully. So if that technique interests you with SVG and CSS custom properties, you should check out this article by Sarah Dayan at frontstuff.io. It's got this whole technique explained really, really well. So back to responsive images and the idea of preloading assets that we need early. One thing that gets complicated with responsive images is if you're trying to speed up their loading. Preloading images tends to be less straightforward when you consider that some resources will fetch differently depending on the device. With responsive images, it's possible to do, but we want to make sure we really need to do it because, again, many images can safely come in a little later. So if you wanted to, technically you can pair link-rel preload to kick off image requests at a higher priority. So the media attributes on a link-rel preload element must match for the asset to be requested at all. So that's pretty neat. You can start to build these up to pair with your picture element and preload the image that'll eventually match later in the page and get that to download at a higher priority. Worth noting that it's interesting that you can do this, but it's probably overkill for most of your images in the page. So I just wanted to note that it's possible to preload responsive images, but I would say do this sparingly because you can see how quickly it can get overcomplicated. And since I mentioned picture, there's also support for matching source set and sizes on image elements with preloading too. And that really looks something like this. There's a link-rel preload with a new attribute called image source set, and that matches an image with source set on it. So image source set and image sizes are attributes we could put on the link element now to sort of preload a image source set, responsive image. So we have tools for both of these. And since preload fails gracefully in browsers that don't understand it, it's okay enough to use. It just won't work everywhere. It won't preload the image sooner everywhere. So there's a push and a pull when it comes to loading images efficiently because we don't want all images to load quickly. We actually want some images to load only when they're needed, which could be much later in the page loading experience. So one thing about images is that generally if they're referenced in the HTML, they're going to get fetched. And a lot of the time, users won't even see all the images that get fetched if they don't scroll that far down. So that's bad for data consumption. Even if they load into the page responsibly, you can see with a page like this, things would get quite heavy. So for images that are not in the critical rendering area, we can help performance and data consumption by loading them only when necessary. So one thing to mitigate the weight of these pages is lazy loading the images as they come into the viewport. The BBC does a really good example of this. It actually uses lazy sizes, which is a project by Alexander Farkas. And as you see, as you scroll down the BBC page, you can see images sort of blink into place. So you know it's working. They're only loaded if they're in view. But more recently, browsers have gained support for doing this natively. So you don't actually have to use JavaScript to do it. And you do that by using the new loading attribute. So you can use this on images and on iframes. Image loading equals lazy or iframe loading equals lazy will cause the browser to assess whether an image is in the viewport before it loads it. And it'll fetch them as they enter the viewport. It works on iframes as well, as mentioned here. But it sounds like recently there are some bugs that are still popping up with the iframe implementation. So you might want to check on that before using it. But for loading images only when needed, this is pretty great. So enough about images. What about video? Well, video is a hugely complex topic. So I'll just cover a couple of things with regards to loading performance. So first, the video element is what you'll use to load video into a page in HTML. And it looks just like that picture tag. Actually, because picture came later and it was modeled after video. You can set a source attribute right on the video element, but I like to add source elements inside it to utilize different formats. Like we said in the optimizing section, WebM and MP4 are good video formats to consider. So here we've got 2 sources offered to the browser and a type attribute for each, and the browser will choose WebM if it's supported, and otherwise MP4. And also I like to set a poster image attribute for the preview of the video, and specify that the video should not preload before loading. This is really good for performance. Unless you're really sure, unless the video is the primary feature of the page, then you might want to set this preload equals none attribute and just let the poster image load. And the user can decide whether or not to download the video when they hit play on it or not. So that'll save a lot of data because video gets quite heavy. One interesting thing is, much like the picture element, you can actually use media attributes on source elements in the video element as well to add different sizes of your video, which is great because video, again, gets very heavy. So we have a small video here for viewport sizes under 400 pixels, and then a larger fallback video for screen sizes larger than that. And just like in picture, the first source that matches is the one the browser will use. So here I've got 4 options: WebM MP4 for small, WebM MP4 for large. Now I should note that the technique that I just showed only works in Safari currently. It used to work in many browsers, including Chrome, but they removed support for media queries inside video. So it's still handy, I think. It's sort of harmless. You can use it and get the benefits of the approach in iOS in particular, which is really great if you're just serving up simple videos and you want to serve a smaller size to mobile devices. I'd still recommend it, but in general, we'll have to see if browsers bring support back for this more broadly than just Safari. So that's pretty much it for video. I'm not going to go further into that. Video is a very complex subject, but just getting your markup right for this can go a very long way. So another major blocker to perceived performance comes from fonts. Early on, when we looked at metrics, we talked about how fonts can really interfere and slow down first meaningful paint. So next, let's look at how we can make our fonts load in a more performance-friendly way. As we covered in the metrics, many browsers hide the text of the page while a custom font is loading, a behavior we often call the flash of invisible type. So you remember this, browsers like iOS Safari will hide the text while the custom fonts are loading for quite a while. By default, most browsers will do this for 3 seconds to allow for custom type to load so that the text is shown first in the intended font. But 3 seconds on a web performance timeline is a long time to wait, on top of all the other delays that we're looking at in a waterfall. So we want to do better than that. And now even PageSpeed Insights and Lighthouse will ding you for messing this up and loading your fonts in a way that blocks content rendering, which is great. If you see this error in Lighthouse, you know that you need to improve your font loading approach. So it'll say, ensure text remains visible during web font load. So what you actually want is something more progressive, like this. Up top, we have a timeline with a standard web font, custom web font loading process. And along the bottom, we have a more progressive one that actually shows a default browser font. And then whenever the custom font arrives, we can decide when to allow it to paint in. So that's a more progressive font rendering process. And doing this used to take JavaScript workarounds, but nowadays we can do it with CSS alone. The new CSS font display specification covers several ways of prioritizing the way custom type renders. So here I'm showing font display swap right here, which will immediately render the text in the fallback font that we specify, which in this case is Georgia, and swap in the custom font whenever it loads. So that's what swap does, and whenever nice serif loads, it'll swap in the layout. Other values for font display allow you to block rendering for a duration, or even hold off on showing the custom font until it's in cache on a subsequent page load, so we don't get a reflow. So lots of good options with the font display property. And Google Fonts and other services like that support font display swap now too. You can, in the case of Google Fonts, just specify that you want it in your font package URL if you happen to use their service. So that's really great. And support for font display is really great now too. And given that font loading standards are leaning more heavily on fallbacks to get a nice progressive load, this is a really good time to remember that it's dangerous to use icon fonts, right? Because if 3 seconds pass and that icon font fails to load, you're going to see a fallback. And with icon fonts, fallbacks tend to be pretty irrelevant. It's really hard to get them right. So if fonts are blocked for any reason, you can end up in some really weird situations. I ran into this great icon font failure last year when I was searching for a hotel in Thailand, and this TripAdvisor page had a rating of 4 fax machines and a laptop, which doesn't seem good, I don't think. It also offered me the distance from my current location by horse, which apparently is different than if I went, walking or by car. Anyway, it's very confusing. When icon fonts fail, you get all sorts of randomness like this. So it's best to use other technologies like SVG. So having said all that about CSS only font rendering, there may still be good reasons to consider using JavaScript to load fonts. This is an article that my friend Zach Leatherman wrote about this very subject. One reason to consider using JavaScript is the ability to group repaints of all of your fonts at one time instead of as they all come in and apply to the page. So when I talk about weights or different fonts, we're talking about the bold weight of a font, the italic style of a font. These may all come in as separate font files and render into the page at individual times, and they can all cause a reflow or a repaint in the page that could be disruptive, right? So in this example, Zach chose a font that has 2 weights, regular and bold, and they're both being loaded by JavaScript using the font face API. And it uses a promise interface. So we can say, okay, load font and load font bold. And then when they're both loaded, because the promise has to be satisfied by all the functions that are passed to it, then we can add a class to the document that would allow the CSS to start using all of those new fonts that were loaded, so they would repaint all at once. So that's kind of nice, and you can't really do that easily with CSS alone. For using JavaScript to load fonts is to only load fonts if conditions in the browser are met. In this case, the code is checking to see if a user has their save data preference set in their browser. Navigator connection save data, which is a preference you can set in some browsers to signal that you'd prefer lighter page weights. So make decisions based on this condition if it's present. So if that preference is set, in this case, this code won't load fonts at all. It'll just show the fallback font. So that's pretty neat. And CSS can't do that alone. So that's another case for using JavaScript. And one more that I think is interesting is sort of a similar example to the last one, but it's using the effective connection speed of the browser. So if it seems to be slow, like 2G, then this code avoids loading the fonts at all. So it's saying navigator connection effective type is slow 2G or effective type is 2G. Then don't do anything, but otherwise load the custom fonts in. And that would follow with some JavaScript logic to load the fonts into the page, like we saw with the grouped repaint example in the beginning. So font display swap, again, is what I'd recommend. It's very easy. It's CSS only, but you can take it further if you want with JavaScript. And if you like font loading strategies, well, I have got a treat for you. You should check this post out from Zach Leatherman. He compares all of the common font loading patterns and their pros and cons, so it's really useful. Another thing that can interfere with first meaningful paint are animations. Animations can really help orient or entice the user, but they can also delay information from presenting. And it's important to remember that they can cause your metrics to look bad too, even if things are generally okay from a usability standpoint. I'll explain what I mean by that. Back when I was working on Filament Group's website, we have this opening animation, right? And when we relaunched our site with this new build animation on it, we had been running SpeedCurve on our site. So we were watching their dashboard and getting their emails whenever something changed that was relevant to us regarding our site performance. Well, when this new site launched, we got an email that our time to paint meaningful content was suddenly dramatically worse. And it's because of that build animation. It was actually counting how long it took for the entire hero section to finish painting, which of course took up to 5 or 6 seconds, because that's how long that animation was. So this is a case where you can see changes in your metrics and make decisions based on whether it's worth it to you. And the metric was just doing its work to alert us that that part of the page was taking a little longer, but it was okay in this case. Lastly, one of the most painful and common delays in painting meaningful content comes from an over-reliance on JavaScript to generate content in the page. Again, this is avoidable with good patterns, but it's still kind of a default pattern in frameworks like React or Vue. We've observed in recent years that we can't overly rely on JavaScript for rendering content exclusively in the browser, because it can cause huge delays in rendering. And this is when we get into that range where we have a really fast client response, really fast time to first byte, really fast initial paint, but the initial paints are not meaningful at all. They don't have content in them. So we have an empty section in the middle of our page until that JavaScript can populate it with content. And the code for doing that, while much more sophisticated typically, is problematic when it resembles this kind of pattern. So you have an empty div in your page with an ID on it, like app, and then you've got a function that populates that div with the full content of your page. And to be clear, this is a performance anti-pattern, right? Even though the page statically renders very quickly, it's completely useless until the JavaScript populates it. So we don't want to do this exactly. We want a more progressive kind of load. Fortunately, today's frameworks can render, so to speak, on the server or the client. So it doesn't have to be all or nothing. Here's a snippet from React, for example, on CSS Tricks that renders a HTML file on the server from data. When we say render, it really means it just returns HTML. So this is sort of a fix that many modern frameworks have provided to get away from this performance anti-pattern of strictly rendering on the client side. So rendering HTML on the server, or you might hear it called SSR, server-side rendering, means we get a nice progressive HTML stream into the browser, which is a great pattern. That's what we want. We want to serve static HTML. And it's certainly not the whole story in performance to make a thick client site spin up faster if we just render it on the server, but it's a big part of it. Generally, SSR, or server-side rendering, is a really important and great step if you're using these frameworks. So this is a new pattern that sort of fixes past mistakes in the modern JavaScript framework patterns that we see today. So what we're doing is taking ourselves further to the right on this chart with SSR. But there's another egregious way that JavaScript gets into this metric and messes with it. Personalization and dynamic content are everywhere now on marketing sites especially. And specifically, client-side AB or personalization packages have become popular because they're really easy for non-developers to use. They can often be managed without much integration in the source code at all. And these services are all orchestrated through tag managers that essentially just insert blocking JavaScript tags into your page for third-party JavaScript files, which wreak havoc on a formerly fast site. It can be really tricky to predict the impact of these integrations because they often run on the live website and not always in every staging version of the website. So you might have a really well-performing website in your development code base, but the live site is hampered by these third-party tools that are added to it. So third-party tools tend to impact both the first meaningful content time and the time to interactive metrics. And it's not often our role to debate whether or not these tools should be added, but it's definitely our role to make sure that everyone is aware of their cost. That way, our team can have really informed talks about their value. So those tools that we use can alert us to a problem, and then we can consider maybe this tool is actually causing problems. Maybe we should consider its value to the user and to our own site and see if it's really worth that trade-off. And quite often, as a site ages, there's going to be deletable, sort of crufty JavaScript files that we need to audit regularly to make sure that we're only loading tools that we're using today. Well, this is what the Telegraph found. They deployed this new methodology called just delete stuff and see if anybody notices. And it turned out nobody did. They removed a whole lot of old scripts that were added by teams of the past and sped up their site quite a lot, and it didn't impact anyone. Thankfully, from our community's nagging, tag manager platforms seem to be showing more awareness that their code is a performance issue. So these tools are improving their practices. Adobe's new tool is called Launch, which replaces the Adobe Tag Manager of the past. And I don't want to say that it outright recommends async script loading, but it at least gives you ways to do that, which is an improvement over the past. So if you're using these tools, it's good to look into whether or not you're loading your third-party tools in a way that's as performant as possible, and then look into seeing if your tag manager allows you to do something in a better way. But assuming we can't just remove this madness, we can do some things to make it look a little less bad. There are some options, at least. One of those is to not run dramatic content variation scripts on first-time visits to the site. So instead, we could load them into cache and run them on a subsequent page view, so it's not so costly to the upfront visit. We could also try to load them asynchronously to, again, get them out of the way of the initial content showing up in the page, and possibly only change content that comes further down the page and out of the viewport. So not making big shifts in the content at the top of the page right when the page first starts to render. We can pre-connect any of the scripts involved, as I showed. Pre-connecting especially, just getting the DNS and the server connection made early can help in a really unobtrusive way. And ideally, the more we can move content variation, HTML variation, to the server side instead of happening in the browser itself, the better for performance. And there are great tools today to move a lot of our logic out of the browser and into middle tiers like CDNs. Cloudflare has some great tools like Cloudflare Workers that let us run A/B tests, or other tools that were traditionally run just in the browser at this sort of middle tier that can still add personalization and things like that, but don't have to run in the browser when everything is really critical to run fast and render quickly. So ideally, we want to move things out of the browser and into either the server or spaces in the middleware in between, like a CDN like this. So that's pretty much it for making our time to first meaningful paint faster. Okay, so just to recap this section, we want to think about the main players that go into meaningful paint and getting meaningful paint to happen sooner. So we want to think about fetching assets as early as they need to be fetched, so they're there when we need them. We want to think about not only optimizing our images, but also serving different images to different viewport sizes, connection speeds, stuff like that. With our fonts, we want to think about strategies that show text early and layer in our custom fonts as they are ready without inhibiting reflows too heavily. And then we want to think about our JavaScript, ways to load it so that we're not blocking the content that we've carefully delivered already, and make sure that we're working with third-party JavaScript in ways that is friendly to our content. Speaking of JavaScript, that's a good time to move on to our next section, which is the metric time to interactive.